Hey everybody, this is Garrett with Earth and Time, and today I'm coming to you from Mammoth Lakes, California, on the eastern side of the Sierra Nevada mountains, where you can see a number of these large boulders behind me. So let's talk about what are these large boulders, why are they strewn all over the ground here behind me, and what actually happened here to create some of the topography in this valley. So come join me today. Let's learn a little bit about Mammoth Lakes, California, and about these unique rocks that are sitting out here in the middle of this field. Let's get to it. As I pan around, one thing you'll notice is there's a number of large boulders that are just sitting in the middle of this large field and really this kind of plain. And wherever I look, I can see these boulders strewn all over the region, including up on the sides of hills, here in front of me. And there's such large boulders that clearly they weren't moved by people and deposited there. So what are these boulders and why are they here? Well, first let me set up the scene here, and that is that we're sitting up at about 7,000 feet or so. So you're looking somewhere like 3 kilometers up if we're thinking about the metric system. And that means that we're up at a much higher elevation, a much cooler environment. So during the last ice age that occurred here, which ended in this area between 15 and 20,000 years ago or so, the last of the glacial advances, this whole area would have been covered in snow and large glaciers coming through this region. And those large glaciers would have been coming off of these mountains that we can see around us here. And these ice sheets would be moving towards me, towards the valley that we can see in that direction and the hills off to the east. So as these glaciers were coming down off these hills, what they were doing is they were literally grinding up the rocks and plucking portions of the rocks that make up the mountains in this area and carrying them along with them. We can take a close look at what some of these rocks look like. In this case, we can see this is some kind of granite or maybe even a granodiorite, which is part of what's known as the Sierra batholith or the Sierra Nevada batholith, which was in place here during the Jurassic or during the time of the dinosaurs. And this would have helped feed a series of volcanoes that were erupting in this area really during that late Jurassic to Cretaceous time period. Now, there were a series of pulses of glaciers coming through here. There were some as old as 200,000 years ago, all the way up until even some small glaciers in the area, even up to a couple thousand years ago. So these boulders would have been traveling along with those glaciers. And as those glaciers started melting, they would actually deposit these boulders. Now, what do we call these boulders? These boulders are known as erratics, E-R-R-A-T-I-C-S, erratics. And they're very common in glacial topography, like we can see here. And you can see they can be quite large. So here I am for scale, and this boulder is actually taller than I am, has to weigh tons and tons. And so these were traveling along these ice sheets, moving their way out into the basin. And as the ice melted through a series of these events, these rocks would fall out of the ice or from on top of the ice potentially, and then just be deposited across this landscape as a series of erratics that we can see dotting the landscape here. And all these erratics, what's interesting, are actually all made up of this granite or this granodiorite, which gives us an idea about what was actually exposed in the mountains during this glacial time period. Now, there's still a lot of granite up in these mountains. You can see it farther behind me, but a lot of what we see close to us now is mostly made up of volcanic material associated with the Long Valley caldera, which I'll do another episode on here shortly. So knowing that we don't see a lot of granite off in the distance, and it's mostly this younger volcanic unit, it tells me that a lot of these chunks of granite had to travel some distance in order to get here, and where they traveled from is probably somewhere over those hills in that direction or over the hills in that direction, and they were transported miles and miles on these large alpine glaciers and then deposited here as those glaciers started to melt and retreat back into higher elevations. So this is a little bit about the geology of erratics and how they form and how come if you're driving somewhere where there were once glaciers, you'll see these big boulders sitting around in the middle of the plains. Everybody wonders, well, how the heck did they get there? It doesn't make any sense. It was these glaciers transporting them. We're going to go look at some other glacial effects here, things called moraines, down at a place called Convict Lake, which has some of the best moraines I've ever seen, which is basically where a glacier was coming down off the mountain and it was carrying a bunch of not just boulders with it, but a bunch of debris. And as far as it goes, it actually deposits kind of a rim of that debris around. And we call those moraines. We have side moraines and what we call terminal moraines. And we'll go take a look at both those down at Convict Lake. All right, everybody, now we moved up towards Convict Lake, and what we can see behind us on these hills, the lowest hills are actually what we call glacial moraines, or where a glacier came and actually ground down a bunch of rock and deposited it where it ended its final destination, if you will, or as far as it would actually travel. So we're going to drive up here. Let's see if we can take a closer look at some of these and check out Convict Lake. So I've moved up the road a little bit, and I just wanted to show you a nice overview of the valley, including to the right of me. As I look off in this direction, you can see we're coming over a hill in front of me, and this is actually the terminal moraine for the last glacier that came through here. And you'll see I'm at a little bit of a lower rise than the other moraine, which we can see this hill on the other side, and you can see all the erratics on the side of this hill as well. So this tells me there was a much larger glacier that came out at one period of time, and then we can see there's a little rise down below. So this would have been a smaller glacier. It eventually terminated right where I'm at on this little break in the slope. And we can see that same relationship if we look in the other direction as well. We can see the lower, younger slope here related to the latest glaciation. And then we can see the other layers going up. And we can get an idea as geologists about the different times of the glaciers or different timing of different sets of glaciers as they advanced in the valley and then retreated over and over again. And you can also see a really nice moraine here. And we're going to get right underneath that moraine over there next to Convict Lake at our next stop. All right, we've made it up to Convict Lake proper, and you can see how absolutely stunning this is. And you can get an idea about this being a glacial valley, which means it's actually has a U shape as opposed to the V shape you think of with valleys that are just from rivers. And the other thing we can see here is if I take a look to the right behind me on this hill slope is actually one of those moraines. So as the glacier came out, it was grinding rock and pushing rock out and moving it along the sides of it and in front of it. And so these are the types of features you'll see in this alpine glaciation. So as I point my finger over here, this is where that edge of that glacial moraine is. You'll see where you have the cliff face over here, which is solid rock, and then you can see all this granite material that's across here, which actually created a dam and which helps make Convict Lake how we see it today. If I look up in the other direction, we can see this tall hill on the other side. So this is on the south side, and actually that tall hill is actually a glacial moraine. So that was all carved by a glacier and deposited up there. So this gives you an idea of how large and thick this glacier was as we look around at the topography here. So that's a good, 100 feet up, 30 meters plus up there. Pretty significant glacier was coming down this canyon somewhere probably a couple 100,000 years ago all the way up until about 10,000 years ago. All right, with the stunning backdrop behind me, I think it's a good place to sign off. Thanks for joining me today to learn a little bit more about alpine glacial geology. This is a fantastic place to check it out. If you ever get a chance to come to the east side of the Sierra Nevada mountains, or even places like Yosemite National Park, it's a really cool place to check out as well. So with that being said, if you enjoyed this video, please remember to subscribe. Give this video a thumbs up if you enjoyed the content and learned something. And thanks again for joining me. I really appreciate you all coming with me and learning right alongside of me here on these episodes. So with that being said, thank you. Catch you all in the next adventure. Take care.